Hello Algebra 1 students, welcome to section 8-5 solving quadratic equations by graphing. The good news about this section, it's very similar to finding the zeros of quadratic function you learn in section 8-4. In section 8-4 you learn that there are three scenarios when you find the zeros of the function. The first scenario, if the parabola intersects x-axis two times, there are two zeros of that quadratic function. The second scenario, if the parabola touches x-axis at one point, there is exactly 1 0. And the third scenario was if the parabola doesn't touch x-axis at all, there are no zeros of that function. This is exactly solving quadratic equations by graphing. It's very similar to finding the zeros. Let's get started. Solve the equation by graphing the related function. We have a given equation, guys. 2x squared minus 2 is equal to 0. It's a quadratic equation. We need to turn this equation into related quadratic function by replacing that 0 by the variable y. So y is equal to 2x squared minus 2. This is my related function. In step number 2, you need to create a table of values in order to graph the quadratic function. Remember, we're solving quadratic function or equations today by graphing, so we need to graph. We need a guide when we choose x values. Don't think every time we choose from -2 to 2 or from particular values. Every function has its own start point and the end point. In order to see both parts of parabola are represented, you need to start with finding the x coordinate of the vertex, or the equation of the line of symmetry. Do you remember the formula, guys? X equals -b over 2a. If you look at this equation, there is no x term. No x term, it means the value of b is equal to 0, and the value of a is the coefficient of x squared, is equal to 2. So when you substitute -b, it's going to be -0, which is 0. 2a, 2 times 2 is 4. So the equation of the line of symmetry is 0. This is our guide when we determine the start point and the end point of x. So I'm gonna create table of values, the left column for x values, the right column for y values or the output values, and the middle column for the function itself for the substitution if you are gonna do substitution mentally. Guys, we place this 0 in the middle of that table. I advise my student to create 5 rows, or they choose 5 x values, and we place the x coordinate of the vertex, which is 0, in the middle. We choose 2 values before 0, and we choose 2 values greater than 0. So 2 values less than 0, it means -1 and -2. 2 values greater than 0, 1 and 2. Now I have a guide, and I'm sure 100% when I represent these points, I will have my both parts of the parabola. Guys, now you either perform substitution mentally, or you can input the whole function in the table mode in your calculator, and the calculator gonna do the substitution for you, and you will just need to copy the corresponding y values. Let me show you how to choose that mode in your calculator. In order to perform the substitution, guys, I'm using Casio FX991ES. Guys, if you look at the top right of the calculator, you hit the button mode, and the calculator gonna show you the available modes and systems using this calculator, and we're looking for the table mode. Whatever the number of the table, you hit that number. In my calculator, it's 7. Some calculators, the table mode is number 4 or number 3. Whatever the number, you hit that number. So I'm gonna hit 7, guys. I'm gonna hit 7 because 7 is the table mode. Once you hit 7, you will see there is a window, and f of x equals. How do I write my function 2x squared? Guys, you write the 2 normally. You hit 2, so this is 2. How do I write x? This is the challenging thing. You hit alpha on the top left. There is a button alpha, and the right parenthesis x. Now you have 2x, but we still need to square this 2x, guys. There is a button x squared. If you hit this button, you square the x, so 2x squared, and we need to hit minus 2. So now guys, my function is written to x squared minus 2. Now how do I enter x values? I know my x values start from negative 2 and stops at 2 according to what I determined at the beginning. So the equal sign is working like a confirmation button or enter button in the computer. So you hit equal, and now the calculator suggests to start from 1. I don't want to start from 1, actually I want to start from negative 2, so you hit negative 2 and you press equal. Again the calculator suggests to end at 5. I don't want to end at 5, I just want to end at 2, so I'm gonna hit 2 and confirm my choice. The calculator suggests to order the steps by 1, so you go negative 2, negative 1, 0, 1, 2. This is exactly what I need, so I'm gonna confirm that. And if you look at the screen, don't pay attention to the first column. The first column is the order of the steps, but we look at the second column and the third column. The second column is exactly the x values we determined at the beginning, starting from negative 2. You can go up and down using this navigation button. So when it's negative 2, the corresponding y is 6, so the first ordered pair is negative 2 and 6. Second ordered pair, negative 1, 0, 0, negative 2, 1 and 0, and finally 2, 6. Let's transfer these values to our table and back to our example. Now guys, I can just transfer the values from the calculator. When it's negative 2, the corresponding y is 6. When it's negative 1, it's 0, 0 and negative 2, 1 and 0, 2 and 6. You can even notice the symmetry from that table. If you look at the first value in that table, you will see 6. This is exactly like the last value. There is a kind of symmetry. The one before, just like the one before, there is only one unique point. This is exactly the vertex of that parabola. So we can even notice the symmetry from the table. If we start with finding the x coordinate of the vertex at the beginning, this is our guide in order to see this beautiful symmetry. Now let's go to the coordinate plane and graph our function. Negative 2, 6, negative 2, 6. This is exactly here, so this is my first point. Negative 1 and 0, negative 1 and 0. This is my second point. 0, negative 2, 0, negative 2. I should go down 2 units. Exactly on the y-axis. 1 and 0, see the symmetry guys. 2 and 6, 2 and 6 is on the top. Now let me connect my points. Remember guys, you're not allowed to use a ruler in order to connect these points. It's a smooth graph, so you need to use your handwriting. You connect with your own hands. Try to be accurate as you can, as much as you can. So guys, this is my parabola, and now it's time to finish this problem with step number 3. Step number 3, graph the function. Step number 4, find the solution or solve this quadratic function by graphing. Where are my solutions? My solutions are exactly the zeros of the function. As you see from the graph guys, there are 2 zeros. This parabola intersects x-axis at negative 1 and at 1. So the solutions are negative 1 and 1. Negative 1 and 1 are the two solutions of this quadratic equation. Let's have another example. Here is my second example guys. The given quadratic equation, negative x squared minus 4x minus 4 is equal to 0. Remember step number 1, we write a related function. We replace that 0 with the variable y or f of x. Y equals negative x squared minus 4x and finally minus 4. Here is my function. In order to determine the start point and the end point in my table, I need to start with finding the x coordinate of the vertex. I recommend that x equals negative b over 2a. you saving a lot of time and a lot of effort if you start with finding this. Guys, the value of a is -1. A equals -1, and the value of b is equal to -4. If I plug these values in this equation, I will get my x coordinate of the vertex. -b, it means -4, it's going to be 4. 2a, it's 2 times -1, simplifies -2. 4 over -2 going to be -2. So my x value of the coordinates of the vertex is going to be -2. This is my guide. I'm going to place this -2 in the middle of the table. 5 x values are enough. If you want to do more than 5 values, it's up to you, but at least 5 x values, and the x coordinate of the vertex has to be in the middle. 2 values less than -2, 2 values greater than -2. The 2 values less than -2 are -3 and -4. The 2 values greater than -2 are -1 and 0. So guys, if you're going to use a calculator this time, after you finish writing this function, this quadratic function, you choose to start from -4 and you end at 0. Not every time we start from -2 to 2 or from particular values. Every function has its own start and end points. Guys, I'm going to save some time and finish all this work on the calculator and transfer my points to this table directly. When it's -4, the corresponding y value is -4, -1, 0, 1, and -4. And if you look at the values, if you compare the first one to the last one, the one before, like the one before, guys, I have done a mistake. This is -1. See, the symmetry guides me to figure out my mistakes. Now let's start graphing this quadratic equation. -4 and -4 is gonna be right here. -3 and -1 in that place. -2 and 0, -2 and 0 exactly on x-axis. -1 and -1 is gonna be here. I expected that because of the symmetry. 0 and -4, 0 and -4 is just right there. Remember, guys, we're graphing a parabola, a smooth graph, so we need to use our handwriting, no ruler. And the right part of that parabola is just like the left part. They are symmetrical parts. This is my parabola. Remember, guys, this is at 0. So I'm looking for the solution of this quadratic function, and the solution is exactly the zeros of this quadratic function. How many zeros for this parabola, guys? This parabola only touches x-axis at -2. So the solution of this, or this quadratic function, only has one solution. The solution is -2. So there is only one solution for this quadratic function. If you remember, guys, in part A, there were 2 solutions. In part B, there is exactly one solution. Let's see the third scenario and look at part C. In part C, we're given another quadratic function, but this equation is kind of tricky one because it is not equal to 0. In order to write the related function, you have to make sure this equation is equal to 0. In order to set this equation equal to 0, you need to get rid of this 4x. So let's minus 4x from both sides. Let's minus 4x and minus 4x. And write our equation in the standard form. So we're gonna start with x squared minus 4x. Remember, we have plus 5 on the left hand side. Everything is equal to. Now 4x and the -4x, they cross out each other. So the equation is set equal to 0. This is a very important, guys. It's very tricky equation. Now when we write the related quadratic function, we replace this 0 with y and we copy our equation. So our equation is going to be x squared minus 4x plus 5. Let's find the x coordinate of the vertex. It guides us to start from what value and to stop at what x value. So my a value in this equation is the number in front of x squared, it's 1, and the b value is equal to -4. Remember, the line of symmetry formula is used to find the x coordinate of the vertex, -b over 2a. If you insert those numbers in this formula, -b is going to be -4, negative is going to be positive. 2a on the bottom, 2a is equal to 2 times 1, so it's going to be 2. 4 over 2 simplifies 2. I'm looking for that beautiful x value in order to place it in the middle of the table, and 2 values before, 2 values after. 2 values less than 2, 1 and 0. 2 values greater than 2 are 3 and 4. So guys, after you enter this quadratic function in your calculator, remember we're using the table mode. After you hit the table mode and you write down the quadratic function, you start from 0 and you stop at 4. If you do all of that, guys, you will find 0 corresponds to 0. The corresponding y value is 0, then 2, 1, 2, and finally 0. It has to be 0. Let me just double check that, guys. If I put 4, it's gonna be 16. 16 minus 4 times 4 minus 16, it's gonna be 5. So I done a mistake. This is 5 and this is gonna be 5. Just double check. I transfer the wrong value from the calculator. Now guys, everything is okay. Now let's start graphing this function. 0 and 5. My first value is 0 and 5. 1 and 2, 1 and 2, exactly right there. 2 and 1, it seems like to be the vertex. 2 and 1, it's upward parabola. How do you know? From x squared, it's positive. 3 and 2, 3 and 2, I started to see the symmetry between the two parts. 4 and 5 is my last value, and it's upward parabola as I expected. The parabola opens upward, and here is my beautiful parabola. I need to go down a little bit. Anyways, guys, here's my parabola, and the surprise is there is no any kind of intersection of that parabola and x-axis. So when you think about zeros, how many zeros of that function? There are no zeros. So what is the solution of this quadratic equation? There is no solution of this quadratic equation. So I'm gonna write no solution. No solution. There is no solution of this quadratic function. And in conclusion, guys, there are 3 scenarios. The first scenario, 2 solutions when the parabola intersects x-axis at 2 points. The second scenario, 1 solution if the parabola touches x-axis exactly 1 time. And the third scenario, no solution if the parabola doesn't intersect x-axis at all. Let's finish this section with a word problem, guys. Real life application. It's about a naughty frog. A frog jumps straight up from the ground. Yeah, this frog gonna start jumping from the ground level. And remember, guys, at the ground level the height is 0. The quadratic function, even the frog jump, can be modeled and described by a quadratic function, and it looks like a parabola. The quadratic function h of t, h is the height of this jump, t is the time taken in that jump. So h of t equals -16t squared plus 32t models the frog's height above the ground after t seconds. About how long? This is the question, guys. How long? It means I'm asking you about the time. I'm asking you about the time. How long is the frog in the air? So we need to calculate how long does it take this frog in order to perform this nice jump from the moment it starts to jump to the moment it lands on the ground again. So guys, how do we perform that? We're looking for the zeros of these functions, and the distance between the 2 zeros represents the taken time to perform this jump. So step number 1, you write a related equation just like we done in example number 1. Y equals -16t squared plus 32t. I need the x coordinate of the vertex as a guide. So the x coordinate, this time it's t, not x, but we can use x. It is not a big deal. It's negative b over 2a. B in that example is 32, so it's going to be negative 32 on the top. 2a, it means 2 times negative 16. 2 times negative 16, it's going to be negative 32. Guys, any number divided by itself is equal to 1. So my x coordinate of the vertex gonna be 1, and that one gonna be my guide. So I'm gonna place that one in the middle of the table, and I supposed to choose 2 values less and 2 values greater than 1. Guys, notice we're talking about t, and the t represents time, and the time cannot be negative. So when you take values less than 1, you only take 0 and you stop. It is not possible to see negative 1 seconds. It doesn't make any sense. Time is always a 0 or positive quantity. So I'm gonna stop at 0. I will not take more than less than 0. One value greater than 1, it's gonna be 2. And guys, now I expect to see the symmetry. If we just graph these 3 values, let's hit this function on our calculator on the table mode and get the y values. The y value that corresponds to 0 is gonna be 0, 1 and 16. I'm transferring the answers from the calculator, 2 and 0, but you can double check, guys. Now my values, my ordered pair are ready. Let's go to the coordinate plane and graph this quadratic equation. 0, 0 does make sense, guys, this point, because at the beginning of the time, the frog starts the jump. So time is 0 and the height is also 0. 1 and 16, so after 1 second, this frog jump in the air in order to reach 16, whatever the used unit, maybe it's centimeters, so 16 centimeters. 2 and 0, in 2 seconds, our naughty frog is back to the ground level. So guys, if you connect these 3 points, you would see a parabola. So even the frog's jump is a parabola. Parabolas are everywhere around us, even this naughty parabola, this naughty frog jump. So guys, now let's answer the question. How long is the frog is in the air? How long? It's the number of seconds. So the frog jumps at 0 when the time is 0, and it lands again to the ground when it's 2 seconds. So how long does it take this frog to be in the air? It's 2 seconds. So my answer, how long is the frog in the air? The frog in the air, the frog in the air, how many seconds? 2 seconds. 2 seconds. It takes this frog 2 seconds to perform this nice jump. Thank you very much, guys. Practice well. See you.